So welcome to lecture series on database management system. In today's lecture series, we are going to see about Armstrong axioms under functional dependency. As we have discussed earlier, functional dependency is a crucial concept in database management system, which helps in maintaining the integrity of data. Armstrong axioms in database management system is very essential for defining and simplifying the functional dependency that we have identified within the relational database. So there are a set of rules for defining the axioms. So these rules are classified into two types as primary rule and other one as secondary rules. So under primary rules, we have a set of rules such as axiom of reflexivity, axiom of augmentation, and axiom of transitivity. So what is axiom of reflexivity is that consider there are two set of attributes. One is A and the other one is B. Here B is a subset of A. We can state that the attribute set A holds B. When the subset B is contained in A, then we can say that attribute A holds B, or attribute A functionally defines B. So this property of Armstrong axiom is called as trivial property. So this is the foundational principle which states that if you have a set of attributes, the functional dependency exists between the set and itself. So this is called as trivial property. For example, consider an attribute student ID. We can state that the student ID automatically determines student ID, which is a trivial property or axiom of reflexivity. So axiom of augmentation is that the functional dependency A tends to B or A determines B holds when then we can also say that the functional dependency AC determines BC also holds for any attribute B. That is, let us consider one example. If student ID can determine the student name, we can also say that student ID along with the course code can determine student name and the course code. So this is axiom of augmentation. If any attribute is augmented to both left-hand side and right-hand side of the functional dependency, that dependency holds. Third property is axiom of transitivity. As the name indicates, when there are two functional dependencies such as X determines Y and Y determines Z, from these two functional dependencies, we can say like X determines Z. This is axiom of transitivity. So example for this is if student ID determines course code and if course code determines course name. From these two functional dependencies, we can say here from these two functional dependencies, we can see course code is a common attribute. So we can say like student ID determines the course name. So this is axiom of transitivity. These three axioms comes under the primary rules of Armstrong axiom. Next, we will see about the secondary rules. So we have totally 6 secondary rules. First one is the union property. Union property says that if there is a functional dependency, A determines B, and another functional dependency, A determines C, and if these two functional dependencies holds, from these two functional dependencies, we can say like A determines BC. Here, the determinant attribute is same. So the attribute on the left-hand side is called as the determinant attribute, and the attribute on the right-hand side is called as dependent attribute. Since the determinant attribute is same, we can combine the dependent attributes like A determines BC. So this is also true. So one more example is if X determines Y and X determines Z, we can say that X determines YZ. So this is the union property of Armstrong axiom. Next is the composition property. So under composition property, it states that if A determines B and X determines Y, these two functional dependencies are true. We can say like AX determines BY. Here, the determinant attributes are combined together as well as the dependent attributes are combined together. So this is the property of composition. Next is the decomposition property. Decomposition property is where the dependent attributes will be splitted. So see, for example, if there is a functional dependency like A determines BC, here the dependent attribute BC can be splitted into two different functional dependencies. So this is the splitting of union property. In the union property, we have merged the dependent attributes, whereas in case of decomposition property, we will split the dependent attributes. So if there is a functional dependency like A determines BC, it can be splitted into two different functional dependencies like A determines B and A determines C. So this is the property of decomposition. But if there is a functional dependency like A, B determines C, we cannot split that. So determinants cannot be splitted and only the dependent attributes can be splitted. The next property of Armstrong axiom is the pseudo-transitivity. This pseudo-transitivity property is similar to that of transitivity, where if there are two functional dependencies like A determines B and BC determines D, we can say like of these two functional dependencies, if you see the attribute is B is common. So combining these two functional dependency, we can write like AC determines D. So this is the property of pseudo-transitivity. It is almost similar to the transitivity property that we have discussed under primary rules. Next is the self-determination. Self-determination is similar to axiom of reflexivity. Uh, that is, any attribute can determine itself. That is the property of self-determination. For example, A determines A. If you want to explain with some real-time examples, student ID can determine student ID. So any attribute determining itself is called as self-determination. So the last property under secondary rule is a property of extensivity. If there are two functional dependencies like AC determines A and A determines B, so from these two functional dependencies, we can write AC determines B. So this property is similar to the pseudo-transitivity as well as augmentation property. Similarly, consider the another functional dependencies like AC determines ABC and ABC determines BC. From these two functional dependency, we can write like AC determines BC. So this is the property of extensivity. So under secondary rule, we have seen totally 6 properties, and under primary rules, we can determine, we can see 3 properties. So primary rule alone is alone is sufficient for defining the Armstrong axiom. However, this secondary rule helps in minimizing the steps. Like, so we can define all the gates with the help of universal gate like NOR and NAND. However, we have separate gates for performing separate functions. So this is how secondary rules are applied. Secondary rules are used for minimizing the complexity involved in primary rules. So hope you understood Armstrong axiom. We will meet in the next lecture.